Lesson 5.4 is on complex numbers. So we've previously talked about squares, and probably when you were in like 8th grade or maybe 9th grade, you would see a number like this. And you would say, well, this problem can't be done. But your teacher would say, no, when you take the square root of this, there is no number times itself that would give you -4, and you wanted to write no solution, but your teacher probably said, write no real solution, or no real number. And the reason you wrote it as no real number is because there actually is a solution to this. There is two numbers that multiply together to give you -4 that are the same number. That number is just called an imaginary number. So now we have the real number set and the imaginary number set. Imaginary numbers are used in circuits, so like with electricity. There are few places it's used, just a few, but we still need to go over them. It will be on the ACT, at least I would say one question. So we want to make sure we know how to do these. Plus we need to know how to solve when we have a negative number. So the imaginary unit is called I. I is the imaginary unit. I is equal to the square root of -1. Also, I squared is -1. So these are the ways we're going to convert. So let's just talk about properties. So if I had something like, so this would just be example 1, square root of -5. When you see the square root of -5, what that means is I have the square root of -1 times the square root of 5. And the square root of -1 is the same thing as I. So my answer would be I square roots of 5. Now, when I see a problem like that, when I see something like square root -5, I'm not going to go through this whole process. I'm going to say, okay, I know that the square root of a negative produces I. So when I see that, I'm going to cross that off inside there and put an I on the outside. So let's do this one. Square root -7. So instead of doing this whole process, we know that when we have a negative, it's going to cross off and put an I on the outside. So the answer to this one would be I square root 7. Okay, what about a problem like this? Parenthesis, I square root 5 squared. So here I'm going to square both terms. So I get I squared times square root 5 squared, and I squared is -1, and square root 5 squared is 5. So the answer to this one, a simplified version, would just be -5. Now we're going to work more and more with that. We're going to first go into solving. So let's start with this example for solving. This is a problem like we had in the last lesson. We would have something like 2x squared plus 26 equals -10. So if I was going to work this problem, I knew what x was. I would square it, take it times 2, add 26. But I don't know x, so I have to work in reverse order. So I'm going to start by subtracting 26 from both sides. So I get 2x squared equals -36. Then I'm going to divide both sides by 2. So I get x squared equals -18. Now, all of the problems that we did in the last lesson, when we would end up with x squared, we would always have a positive number here because we didn't know about the imaginary number system yet. So now to get x by itself, I'm going to square root both sides. So I get x equals, and remember when we square root, we have plus or minus square root -18. So then I know that anytime I have a negative under the square root, it's going to put an I on the outside. And then I want to think about the number 18. 18 is 2 times 9. And the square root of 9 is 3. So see where I write the 3? It goes right in front of the I. The I kind of is sort of like a variable in this case, but it represents something. So my answer would be plus or minus 3i square root 2. That's what x would equal.